Okay, our elementary matrices, this one and this one, have been brought over here. Now, the first thing we did to the matrix 1, 0, 3, 0, 2, 4, 1, 1, 0 is multiply by this matrix. So I'm going to multiply, I'll let that be the first matrix that I multiply something by. So if I'm going to multiply what I've got here by another matrix that I'm going to put here, the first one that matrix will be multiplied by is this one. Okay, then here's the other matrix. Okay, that matrix will multiply this one. Now, if I do that multiplication, you can verify quite easily that this is the matrix I end up with. Okay, now, what does this matrix do to whatever matrix I multiply it by? It reverses the first and second row. What does this matrix do? It doubles the first row. So if I multiply by this matrix, it should reverse the first two rows, then double the second row. Okay, well, let's multiply that matrix times our ubiquitous A matrix. Okay, we multiply it, you can easily verify that this is what we get. Now, what would we get from this matrix if we switched the first two rows? Well, we'd get this, right? If we then multiplied this matrix by this, that would double the first row. And if we double the first row of this matrix that we get here, the 0, 2, 4, 1, 0, 3, 1, 1, 0 matrix, we're going to get the 0, 4, 8, 1, 0, 3, 1, 1, 0 matrix. Okay, so multiplying the interchange matrix by this matrix gives us this. Now, we didn't multiply this matrix by this matrix. We multiplied this matrix by this matrix over here, but over here we're multiplying the product of these two matrices by the original A matrix. Okay, which means that the action of the product of these two matrices is to interchange the rows. So we would interchange these rows, which would get us this matrix, even though we wouldn't see it in this product, and then doubling the first row. First row 0, 2, 4 doubles to 0, 4, 8. So if we take this matrix, interchange the first two rows, double the first row, this is what we get. And it's the same thing we get if we multiply this matrix by the product of these two matrices. You could ask yourself, if I did this in the reverse order, if I put this matrix to the left of this one, would I get the same matrix? And then you can ask yourself, well, if I doubled the first row before I interchanged the first two rows, would I have the same result? If I would, then you expect that these two matrices would multiply the same no matter how they're multiplied. In other words, that the multiplication of these two matrices at least would be commutative. If not, if you get a different matrix here by reversing the order of your multiplication, then you expect that reversing the two rows and that doubling the first row, then reversing the first two, would give you something different. So you want to check that out. Some kind of thing you want to think about and play around with, gives you a deeper understanding and a bigger context for understanding everything we're doing.